Assalamualaikum. We continue with the last part of this chapter with the title Rule of 13. The rule of 13 can be used to identify the possible molecular formula for an unknown hydrocarbon. Let's say if we are given or known the molecular weight of the unknown molecular formula of organic compound, so we can use the rules of 13 with the formula CnHm. Step 1, n is equal to m plus divided by 13 because this is rules of 13, so we have to divide by 13. And the next step will be we have to find the value of m. M is equal to n plus the remainder value. Rules of 13, for example, I give here how to determine the molecular formula. The formula of hydrocarbon with m plus is 106 can be found. So how we can find the molecular formula for this molecule with the molecular weight 106? The first step what we need is to find the n value because we have to find the Cn, how much n, and then we will know how much m. So for the first step, the molecular weight will be divided by 13. This is rules of 13. Carbon 13 means, so 106 divided by 13, we can get 8 point something. So we just put the value of 8. And then the next step, we have to find the R value because m is equal to n plus R. So how to find the R value? M plus minus with the n times with the 13. So we get the R value. M is 106, the n is 8 times 30, so we get 104. So the balance will be the 2 value. So now when we get the value of n and R, so we can determine the m. M is equal to n plus R. So now n is 8, R is 2. So total is 10. So the molecular formula for this molecule is C8H10. So this is the step how we can calculate based on the rules of 13. Next example, if m plus is 58, so again the same process. The first one we have to divide by 13, so we got the value of n 4. So we have to get the R value, which is the m plus minus n times with the 13. So we get balance of this m plus minus the n times with the 13 will be the 6. So this is the R value. So m value is n plus R. 4 plus 6 is equal to 10. So the molecular formula for this molecule is C4H10. Okay, if we have found that our molecule have heteroatom, so we have to subtract the mass with each heteroatom from the molecular weight first, and then we calculate the formula based for the corresponding hydrocarbon based on the rules of 13 formula. Add the heteroatoms to the formula after getting the value of n and m. So see example for molecular formula compounds with the heteroatom. If we suspect our molecule to have one oxygen, for example, CnHmO how much? So we have, if we suspect 1, so we have to remain molecular weight become 58 minus with 16. So this is the balance if we suspect 1 oxygen. So the total molecular weight is 42. This 42 we divide by 13, so we have 3 integer, and then we have to find the R value. The R value is 42 minus n times 13, so it becomes 3. So the molecular formula should be, the m value will be the 3 plus 3, so it becomes 6. So CnHMO. So C3H6O. That's how if we suspect one oxygen. If we suspect our molecule to have one nitrogen, we have to deduct with the 14 nitrogen atom mass. So this one is 58 minus 14 become 44. This 44 we divide by 13, so we get the 3 integer for the n value. So next we have to find the r value, which is 44 minus 3, which is n, times with the 13, so we got 5. So we have to find the value of m, which is n plus r. 3 plus 5 become 8. So the molecular formula for our compound will be C3H8N. That's the example for rules of 13. So if we suspect to have 2 nitrogen, same, we have to minus with 2 nitrogen atom, which is 28. So the remain is 30. 30 divided by 13 become 2. This is the n value. So we have to find the r value. So the r value is 4. And the m value will be 2 plus 4 becomes 6. So the molecular for this compound will be C2H6N2. If we suspect our molecule to have 2 sulfur, so we have to deduct with 32. And 58 deduct with 32 become 26, and 26 divided by 13 become 2. This is the n value, so we have to find the r value, which is the r value is 0, so the m value will be 2. So the molecular formula will be C2H2S. Sorry, this one a correction, this one is S, only one S. We expect to have one S only. Actually S is 32. Sorry, this is one correction. So finish for rules of 13. So that means all the notes for mass spectrometry have been covered. Now we have learning check in this slide, which is how we can, after we learn all the subchapter, and then we try to answer this question. Identify the following MS as that of methyl cyclohexane or ethyl cyclopentane based on 2 unknown spectra. So we have to determine which one is belongs to which compound. So how we can determine? So see the example for spectrum A. So see example for spectrum A. If these 2 unknown compound, for this unknown spectrum, which one is belongs to this compound? So we have to see the fragmentation pattern. So the molecular weight will be here. The molecular weight will be 98. So 98 deduct 83 become 15. Here in between 15, we know 15 is the loss of methyl group. So methyl might be here or might be here. So we cannot predict. So see, 98 deduct by 69. So this one become in between is 29. We clear that this is group of ethyl. So we clear that this spectrum is belongs to this compound because the loss of ethyl. In this case, there are no loss of ethyl. So this is the compounds for this spectrum. And next example, if sample B spectrum, how can we determine? So this one, it clearly shown that 98 minus CH3 become the most stable one, this part. So this one, this cation, and this loss of 15, so clear that shown that this is belongs to this compound. So we see how's the fragmentation. So that's all for this chapter. Again, I summarize that all the mass in our lab have been detected by the GCMS. That's all. Thank you.